Okay, now here's a much more challenging problem. First, I want to find the rate of change, the derivative of this rational function. I've got a fraction there where I got a function top and bottom. So C prime, my derivative with respect to time, t, I got to think quotient rule. So F over G, first over second, would be derivative of the top, leave the bottom alone, minus derivative of the bottom, leave the top alone, over the bottom squared. You got to memorize that. So what do we get? Derivative of the top, 2 times 2 is 4t to the first power now. Plus, there's a 1 in front of that t there. 1 times 1 is 1. T to the 0 is just another 1. That's the derivative of the top. Times leave the bottom alone. Minus derivative of the bottom. The derivative of t cubed would be 3t squared plus 0. That's a comma right there after the function. That's not part of the function. The derivative of 50 is just 0. So there's G prime. There's the bottom derivative times leave the top alone. All over the bottom squared. Squared. Don't forget your squared there. Okay, now this C prime at 12 would be, I could plug in a 12 for all those t's. Oops. 12 cubed plus 50 minus 3 times 12 squared times 2 times 12 squared plus 12 in parentheses all over 12 cubed plus 50, and then whatever that is squared. Okay, I'm not going to make you watch me type this in a calculator, but that is something you'd want to be very careful of. Now, what does this mean? A derivative is always a change in your function per change in independent variable. So this would be measured in milligrams per liter per hour. Milligrams per liter per hour. So that's change in C over change in T. And so what we would say is at 12 hours, I don't even know what we're measuring here. The concentration of the antibiotic would be increasing or decreasing, if this is a negative number, by that number at a rate of milligrams per liter per hour. This is the rate of change of the concentration at 12 hours. That's a good place to stop there.